let's go over common factoring. I have this big trinomial. Trinomial is something that has three terms, okay? And to common factor, we need to look at each of the coefficients, and the coefficients are the numbers in front of the variables. And we need to look at the variables, okay? We're going to focus on the coefficients to start. I'm going to look for a common factor in all of these. Now, I might be able to look at all three of these and be like, this is the common factor, but maybe I can't. So a way to set this up, if it's not 100% clear to you, is to write the factors of each of these terms. So number 3, well, the factors of 3 are 1 and 3. 12. Factors of 12 are 1, 12, 2, 6, 3, 4. And then the factors of 27 are 1, 27, and 3, and 9. That's it. So I look for a common factor. Well, 1's always a common factor, and really doesn't help. It changes nothing, so we don't really count that one. And usually we try to look for the greatest common factor. And if you look closely, 3 occurs in all of these. So that means 3 can be divided evenly into every single one of these terms. So I'm going to divide all 3 of these by 3. The other thing about this is the variable. And sometimes it can be hard to see. Oh, a common factor of a variable. Well, let's think of it like this way. 3 cubed can also be written as x times x times x. In other words, 3 of them. X squared could be written as x times x, and x can just be written as the value of x. Well, what we do here is we try to take out the same amount of variables from all 3, as many as we can, okay? So because I can only take 1 out of this guy, maybe I should use a different color there. Because I can only take 1x out of him, I can only take 1x here and 1x here. So in other words, I can only take x out. And when I do that idea, I'll do it right in green here. So we're only going to take x out. Only to see what happens. In this one, when I take an x out, there's nothing left. In the x squared, x is left. And in the x cubed, 2 x's are left, or x squared. This is the same concept, I'm going to write on the side here, as an exponent laws rule, where it looks like this. X cubed divided by x. Well, x is technically to the power of 1. So I can rewrite this as x to the power of 3 minus 1, which is equal to x squared. And that's what we got, 2 x's. If I have x squared, so we'll do each single one of them, divided by x, technically that's to 1, so it could be written as x to the power of 2 minus 1, which is just written as x, and that's what we got here, just x. And finally, whoops, x divided by x, well, they're both to the 1. X to the power of 1 minus 1 is equal to x to the power of 0. X to the power of 0, or any number to the power of 0, is actually equal to just the number 1. And there's nothing left here. We assume it's times 1, number 1. Okay? So that's kind of the exponent thinking behind it. You don't have to go through that process every time, but that really broke down every step. So from there, my common factor is 3x. I'm going to write it all in red here instead of 2 colors. Christmas looking. 3x is the value we took out, so it has to be written. The brackets are then what's left over from each of these. So when I divide 3, oh, go away, please. When I divide 3 by 3, I get 1. And when I divide x cubed by x, do you remember what that gives us?
X squared?
Yeah, x squared. Now, do I need to write that one?
No.
No, so we won't leave it in. Okay. And our next one, negative 12 divided by 3 gives us what number?
Negative 4.
Yep, negative 4. And x squared divided by x gives us?
X.
Just x. And positive 27 divided by 3 gives us?
5? No.
Close.
9.
9. Good. Positive 9. And x divided by x is?
Nothing.
Nothing. And that's it. We've now common factored. Okay. And then I can look at this trinomial and try to factor. Is actually really not a nice way, so we're going to finish it here. But this is our common factoring. And there's tons of background stuff going. It looks like it's really quick in one step, but if we don't know all of these little things in the back, this can be a really confusing process. Okay?